Welcome to Design Technology in Key Stage 2. This is a dedicated presentation for the Flying High Partnership and is delivered by Lawrence Keel. This presentation is designed for school leaders, design technology subject leads and teaching and learning staff in Key Stage 2. In this presentation we are going to cover the following: a brief overview of the design technology curriculum in primary schools and some of the underlying principles that can be applied when designing a scheme of work for the subject to ensure effective teaching and learning in the subject and to secure the best outcomes for the children in design technology. We should touch briefly on the pedagogy of teaching design technology using 4 different types of lessons. The main focus of this presentation is looking at detail at the curriculum content for the subject. First, we will look at the disciplinary process and how the subject works in terms of developing knowledge of designing, making and evaluating in Key Stage 2. This includes sections on the importance of teaching vocabulary and learning about designers and their designs. This will be followed by an in-depth look at the curriculum content in the strands of learning relevant to Key Stage 2. Having considered the curriculum content, we will complete this presentation with how to support children who may struggle or excel in the subject and how to construct a curriculum that ensures children progress to the curriculum endpoints and how an effective progression map can be used to drive assessment in the subject. Throughout this presentation we will stress the importance of building upon children's knowledge and learning experiences gained in Key Stage 1, and also how children's knowledge gained in lower Key Stage 2 needs to be built upon and extended as children progress into upper Key Stage 2. Design technology at Key Stages 1 and 2 should build upon children's learning from their experiences in early years. An effective early years unit will lay the foundations for children's future learning in design technology. In the early years, children should have the opportunity to explore and investigate a range of products, materials and tools, finding out how they work and how they can be used. They should experience making and constructing things using a variety of materials and tools. Children should experience exploring food and making simple food products, and through this will begin to learn some simple cooking and food preparation skills. In all these learning activities, children will be talking about their experiences, asking and answering questions, learning new words and giving their views and listening to the views of others. Effective provision for design technology based activities is covered in more detail in the separate presentation for the Flying High Partnership. The aims of the National Curriculum for Design Technology is to provide children with the knowledge, skills and expertise to participate successfully in a world where technology is advancing rapidly. It encourages creativity in children by challenging them to design and make a range of products that could be used by a wide range of users. As part of this creative process, it encourages children to evaluate, reflect upon and test out their ideas. To support them in this process, children should learn about people who are successful in the world of designing and making and have made a significant contribution to advancing technologies. A significant part of the design technology curriculum in primary schools is devoted to children knowing, understanding and applying the principles of healthy eating and nutrition when learning how to cook. These are a summary of the aims of the national curriculum. It also provides guidance on teaching children the knowledge, understanding and skills that they need to design and make products, as well as a brief overview of the technical knowledge that children need in order to design and make their products. When designing and making their products, children should work in a range of relevant contexts, meaning that the products that they are creating should be relatable to the real world and relevant to the children's lives. Whilst design technology can be considered a practical and creative subject where children apply a range of skills and techniques, at the heart of the curriculum must be the knowledge that the children need to learn to be creative and successfully carry out those practical skills and techniques. Using the content from the national curriculum, all the knowledge that the children need can be split into two distinct areas of knowledge. First, there is the disciplinary knowledge that focuses on how the subject works and the creative and iterative processes of designing, making and evaluating. And as part of that process is the importance of children developing a technical vocabulary and also knowing about successful designers and inventors who do the subject well. Because if you want to know how a subject works or to get better at the subject, then study the people who do the subject well. Second is the technical knowledge, and this includes developing knowledge about products, knowing how they work and how they are made. Using guidance from the national curriculum, this learning can be divided into 6 strands of learning: cooking and nutrition, materials including textiles, structures, mechanical systems, electrical systems and program systems. At Key Stage 1, children are focused on cooking and nutrition, textiles, structures and mechanical systems. And when they transition into Key Stage 2, they widen this focus to include electrical and program systems. This diagram shows how the curriculum can be implemented as a progressive scheme of work that delivers the curriculum endpoints at the end of Key Stages 1 and 2. Through studying content in the 6 strands of learning from Year 1 to Year 6, children acquire the knowledge and experiences of designing and making and evaluating products, whilst also gaining the technical knowledge, practical skills, vocabulary and the knowledge about designs and designers associated with each strand of learning. And this diagram shows one way of delivering the strands of learning in a curriculum long-term plan for design technology, where design technology is taught once each term. Such is the importance placed on cooking and nutrition within the national curriculum that a unit of work is taught each year that focuses on cooking and nutrition. Materials, and this is often a textile-based project, is taught every other year, as our projects focus on building structures. The final strand has the common thread of systems, in which children include either a mechanical, electrical or program system as part of their product. It would be expected that these products would be more complex as the children get older, and it is likely that products developed as part of the electrical and program system projects would also include elements of children's learning about materials and structures. As well as ensuring that your school curriculum meets the requirements of the national curriculum, here are some other areas of curriculum provision that you might want to think about. Time allocation. There is no specific guidance about the amount of curriculum time that should be devoted to teaching design technology. Most schools have opted to teach the subject over 3 half terms during the academic year, and this is the approach that we have taken in our scheme of work. The key question to ask yourself is whether children are reaching the expected standard at the end of each key stage, and as part of this, whether the curriculum is covering all areas of the design technology national curriculum. If the answer to either of these questions is no, then a key line of inquiry should be whether enough curriculum time is being allocated to allow the children to have the breadth and depth of learning in the subject. Linked to the amount of time allocated to the subject is the method of delivery in terms of how many topics are covered in each year group and how many lessons are used to deliver each topic to ensure curriculum coverage. Also worth thinking about is how the lessons are delivered over a unit of work. Are they delivered weekly with an opportunity for children to revisit, recall and consolidate previous learning? Are they delivered over a series of lessons during 1 week? Some schools have a design technology week each half term, with every afternoon devoted to the subject, or are they delivered as a design technology day with all the learning compressed into 1 day? Each of these approaches have their merits and their pitfalls, and different approaches work for different topics. What needs to be decided is what method of delivery for each unit of work produces the best outcomes for the children. Referencing how the subject is delivered should form part of any curriculum statement for design technology. In thinking about the curriculum content, breadth is important to ensure that the national curriculum is covered so that children receive their statutory curriculum entitlement. But the design technology curriculum is potentially vast, and you cannot cover everything in depth, and so choose certain areas where the children will have opportunity to go deeper into the subject. So for example, if you are lucky enough to have a school garden or allotment, you could shape your cooking and nutrition units so that the children include ingredients that they have grown themselves. Or if you have woodworking equipment as part of your resources, you can include 4 or 5 units where the children create wooden frameworks as part of their learning across key stages 1 and 2. Or you could include elements of enterprise and entrepreneurship in your design technology units, with children creating products to sell to parents or at a school event, and make this a theme of design technology, particularly in key stage 2. Whatever topics you choose to include in your curriculum, have a clear rationale for the choices and make sure that this is articulated through your curriculum documentation. Resources. Design technology as a subject has the potential to be resource heavy, both through specialist equipment and also through consumable materials. In developing a curriculum, first undertake an audit of your current resources and see whether you are able to deliver the curriculum using these existing resources and working with what you have. Also, a tight scheme of work that clearly identifies the products that the children will be creating, along with the materials, tools and techniques needed, will allow the school to resource the subject more efficiently and buy only what you need. Also consider how the subject will be taught. For example, if the school does decide to include several projects that involve woodworking, then it is likely that practical sessions would be done in small groups, because you're unlikely to want to have 30 children all sawing wood at the same time. So you would only need to resource for maybe 6 saws and bench hooks. The same kind of approach applies to cooking and nutrition lessons, and whether the practical elements will be taught in small groups, half class sizes, or the full class. Resources for program systems and some elements of mechanical systems can be very expensive, and schools may wish to consider partnering together to share resources. However, this may mean aligning certain parts of your scheme of work. Cross-curricular links. Many primary schools follow a topic approach to teaching the foundation subjects, and often the driver for these topics are either history or geography related. This leads to teachers trying to link design technology learning to the ancient Greeks or to the Brazilian rainforests. As will be discussed later, one of the principles of effective design technology is that children design and make products that are real life and relevant. So designing and making a Tudor house or a Mayan headdress is not particularly real life and relevant to the children's experiences of Britain in the 21st century. Also, in using a cross-curricular topic approach, weaker subjects tend to be forgotten or badly taught, and so teachers who are not confident or lack subject knowledge tend not to teach the design technology content properly as part of cross-curricular work. If you do go down the route of cross-curricular topics, ensure that the DT content within the topic is clearly identifiable and matches the scope and ambition of the national curriculum. Within the DT curriculum, there are opportunities for children to apply their knowledge from other subjects, particularly subjects like maths, science and computing. And here we are looking at key skills such as measuring from maths lessons, applying the knowledge of properties of materials and simple circuits from science lessons, and using block coding to control products and computer software to design products from the computing curriculum. Considering this transference of skills and knowledge from one curriculum area to another, highlights the need for curriculum coherence. And this is about ensuring that if we are asking the children to transfer these skills and knowledge that they have already been taught them in these subjects, what we want to avoid is using valuable DT time to teach or reteach learning from elsewhere in the curriculum. Health and safety. Teaching design technology, due to its practical nature, can introduce an element of jeopardy into lessons. Part of successful and effective planning for each practical lesson is about reducing the risk. Risk assessments are not worth the paper they are written upon if they are written and reviewed every 3 years and then put away in some dusty cupboard and then signed by the teachers every September so that the school shows some degree of compliance. Risk assessments need to be a live document that reflects the current situation, the activities that are to be undertaken, and the nature of the children taking part and the risks involved in that particular lesson. As part of reducing this jeopardy, schools should have clear guidelines for the practical elements of design technology in terms of group sizes, techniques that are taught, and where additional adult support is needed. Make sure that staff receive appropriate training in teaching the techniques correctly and that all staff adhere to these routines and receive regular refresher training. Also, choosing appropriate resources can help to reduce the jeopardy. For example, when teaching children to grate carrots, make sure that all the graters are of the same design and size so that the children only need to know one technique. Staff need to be able to demonstrate due diligence when teaching practical activities and demonstrate that they have actively sought to reduce the risk. Finally, when considering the curriculum in DT, it is worth noting the soft skills that are often developed in the subject, such as getting organised, working as a team, discussions and decision making, cooperation and resilience. These will not happen by accident, and there may be times within lessons where these soft skills may need to be taught, or certainly children will need support in order to develop them. This may be another area that you want to include in any curriculum documentation in design technology. In our scheme of work, we include teaching slides and opportunities to help teach and support these vital soft skills. As part of the support package for schools in the Flying High Partnership, 2 audit documents are available for download from the Primary DT website. The Audit of Provision is a self-evaluation tool that focuses on curriculum provision. It is divided into several sections that address national curriculum coverage, design technology in the early years, the principles of design technology and how they are applied to the curriculum, how disciplinary knowledge and understanding is developed through the curriculum, the technical knowledge of design technology, and progression and assessment in design technology. Many of these areas are covered in this presentation. The second audit focuses on staff confidence and capability in the subject. This is a questionnaire for teaching and learning staff to complete that focuses on their confidence, knowledge and skills in teaching key areas of the subject, their understanding about key themes linked to disciplinary knowledge of designing, making and evaluating, their subject knowledge of techniques linked to the 6 strands of learning in the design technology curriculum and other areas such as health and safety and drawing techniques. The outcome from compiling the results from this survey may highlight the strengths and weaknesses in staff subject knowledge and point the way for further staff training and development. Research has shown that staff subject knowledge and the confidence to teach the curriculum content is the biggest barrier to effective teaching and learning in design technology. For those of you choosing to use the curriculum audit, Section 1 covers the content from this first section of the presentation, including curriculum provision linked to the 6 strands of learning in design technology. In this section, we are going to summarise the 5 principles of design technology that act as a driving force behind the development and implementation of a quality curriculum in the subject. These are the 5 principles that guided the development of our scheme of work. A more extensive overview of the principles are provided by a separate webcast available through the website. The 5 principles are listed on the screen now. They are: when working on a design technology project, children should create a product by both designing it and making it. For teachers, when developing a project or a unit of work, they first need to decide on the product that the children will create and then work backwards by identifying all the knowledge that the children will need to successfully create the product and finish the project. Perhaps the most important part of implementing a quality DT curriculum is the concept that children will be building their knowledge as they progress through the curriculum. So in each unit of work, children are revisiting prior knowledge, learning new knowledge, and connecting all this knowledge together to create a better understanding of the subject. For each product that they are creating, children should be making decisions about the design that makes their product innovative and authentic to them. It is highly unlikely that children will design something truly unique or innovative, but instead their designs are likely to be based on a similar product to which they adapt with their own unique ideas and creativity. In making these design decisions, children need to consider who they are making the product for and what is the purpose or function of the product. Technology is everything created by humankind. Understanding technology and how it is made and used helps children to understand the world around them. So, when working on DT projects, it is important that children are creating products that are real life and relevant to them. The final principle is that when children are creating a product, they should understand and apply the iterative process of designing and making. The iterative process in design technology is about the cycle of continuous improvement. It is about repeating the series of steps that are needed to create a product, with each repetition refining the previous version based on evaluation, feedback and testing of the product. This ultimately leads to continuous improvement and a final better product. Hopefully, most people understand the simple disciplinary processes of designing and making and evaluating that are needed to create a product. But if we include the iterative nature of the subject, the process should not be viewed as linear, but more of a cyclical nature, where, for example, we might evaluate designs and improve them before proceeding to make the product, the proverbial back to the drawing board. Or, as part of the creative process, we might make a model of a product, evaluate what we like about the product model, and then use this evaluation to inform the designs we create. In practice, with limited curriculum time for the subject, what we need to install in the children is the mindset of thinking about how can I improve my product as an ongoing process and not leave evaluation activities to the final lesson at the end of the unit of work. For those of you using the curriculum audit, Section 3 is dedicated to ensuring that your curriculum delivers these 5 principles. It is recommended that you watch the separate webcast on these 5 principles before completing Section 3 of the audit. In this section, we are going to cover some pedagogical approaches to teaching design technology. Knowledge lies at the heart of the curriculum in design technology. This knowledge can be divided into 4 main knowledge domains: subject knowledge, technical knowledge, disciplinary knowledge, and practical knowledge. Essentially, teaching design technology is about providing children with that knowledge and then providing opportunities for children to apply this knowledge when creating a product. As children progress through the curriculum, they will know about products that they are designing and making and how these products work. They will know about techniques and processes needed to design these products. They will know about the skills, techniques, tools and materials needed to make these products. and they will know how to evaluate the products they have made and know how to identify ways to improve them. And through this knowledge acquisition and building, they will know more about the subject and how it works and the iterative nature of design technology. So, when planning a sequence of lessons or learning activities, teachers need to identify and understand the knowledge that the children need in order to achieve the learning outcomes for the activity, for the lesson and for the unit of work. This can be helped by having knowledge-based learning outcomes, which state what the children will know at the end of the lesson, or a skill or technique that they will know how to do at the end of the lesson. Research has shown that teachers' lack of subject knowledge in design technology is the biggest barrier to effective teaching and learning in the subject. Therefore, if there are any concerns about the quality of provision in the subject, perhaps the best place to start would be to focus on professional development to improve subject knowledge. Effective teaching and learning can also be supported by providing detailed planning or a scheme of work that clearly identifies the knowledge content for each lesson and each unit of work. Another highly effective strategy for improving subject knowledge is for staff to make the product that the children are going to create. Doing this before the project begins allows staff to identify all the knowledge, skills and techniques that are needed to make the product, and also to begin the process of sequencing this knowledge acquisition into a series of learning activities and opportunities. As children progress through the curriculum, they should be building and linking their knowledge and getting better at a range of skills and techniques. Therefore, as well as identifying the knowledge that children will know within a lesson or unit of work, teachers need to know what children know already, how much they have remembered, how secure this knowledge is, and whether further learning activities are needed to consolidate this existing knowledge. And when delivering new knowledge, how can it be linked to existing knowledge to create a better understanding? This highlights the importance of effective assessment for learning strategies in the subject. In a sequence of learning across a unit of work, there should be opportunities for children to consolidate existing knowledge, acquire new knowledge, and then apply this knowledge. This learning sequence can be delivered through 4 types of lessons. Units of work normally begin with a series of investigative and focused tasks. These are followed by the design and make task, where children have the opportunity to apply the knowledge, skills and techniques they have learnt in order to create a product. Through the investigative tasks and the focus tasks, children are provided with all the necessary learning and prerequisite knowledge that will allow them to successfully complete the design and make task. In investigative tasks, the teacher guides the children through investigations that allow them to find out and gain more knowledge about a product. Investigative tasks are about finding out about existing products that are similar and linked to the product that the children will be creating in the design and make activity. In the evaluate lesson at the end of the project, children have the opportunity to evaluate the product that they have created, but also to reflect on the processes that they have used and also on the project as a whole. Through participating in the design and make activity and the evaluation tasks, children will be consolidating and developing their understanding of the disciplinary knowledge of design technology and how the subject works. Having lessons that are knowledge-based will affect how the lessons are delivered and the role of the teacher within the lesson. For investigative tasks, the teacher guides the children through the investigations to ensure that from these tasks, children acquire the knowledge that they need. Investigative tasks are about finding out about existing products that are similar and linked to the product that the children will be creating in the design and make activity. Focus tasks are instructional activities that focus upon improving pupils' knowledge, gaining new skills, and improving and consolidating existing skills and techniques. Tasks can be designed to provide children with the knowledge of how a product is made or to practice key skills that are needed to make a product.
Through focus tasks, children can learn about how to use tools properly and can develop a deeper understanding of the properties of materials and or the ingredients that they are working with. Focus tasks are an opportunity to provide specific technical knowledge of how a product works or how a system to be used in a product functions. Focus tasks are also an opportunity to teach children the specific skills and techniques associated with the disciplinary processes of designing, making and evaluating, such as developing their designing skills using mood boards, brainstorming, different drawing techniques and computer-aided design. They can be used to teach children how to conduct research through questionnaires, surveys, desktop searches and taste testing. They can be used to make a system to understand how it works and how it can be used in the final product. Focus tasks can also be about learning how to make a generic food product by following a recipe which then children will adapt as part of the design and make activity. Focus tasks can also be used to teach children specific evaluation techniques. For these focus tasks, teaching is likely to be quite didactic, with all the children creating the same product or having the same learning outcome. The design and make tasks provide the opportunity for children to apply their learnt knowledge and understanding. There should be no new teaching of knowledge. Children should have all the necessary prerequisite knowledge to design and make their product. The teacher can support children in these sessions whose knowledge or application of this knowledge is not secure. In design and make sessions, the teacher acts as a coach or critical friend, stepping in when necessary to keep the creative process moving along and ensuring that children create their product. In the evaluation sessions, the teacher can lead and support the process of evaluating the product, providing prompts and ideas. But, like the design and make sessions, these should be very much led by the children. Design technology is a disciplinary subject, and to be successful in this subject, children need to be able to understand and apply the creative processes of designing, making and evaluation, and how they interact with each other as part of the iterative process and nature of the subject. As children progress through the curriculum, it is expected that they will understand more about the disciplinary knowledge and the creative processes of design technology and be able to apply them to projects they are undertaking and products that they are creating. And we will begin by looking at designing.
The national curriculum at Key Stage 2 states that children should be taught to use research and develop design criteria to inform the design of innovative, functional, appealing products that are fit for purpose and aimed at particular individuals and groups. They should also be taught to generate, develop, model and communicate their ideas through discussion, annotated sketches, cross-sectional and exploded diagrams, prototypes, pattern pieces and computer-aided design. During Key Stage 1, children will have begun the process of designing products for themselves and other users using design criteria. Throughout our scheme of work, we refer to design specifications instead of design criteria, but they are essentially the same thing. Children will also have developed and communicated their design ideas through talking about them, sketching and drawing, making models of their designs and beginning to use computer software during the design process. In Key Stage 2, these design processes and the creative process of design are built upon and developed further. In order to be effective designers, children need to have knowledge to be able to design products. They need to know about the products they are designing, what they are used for, their purpose, how they might be made, including knowledge of the materials and properties that might be used to make the product, and how they might be made. Having acquired this knowledge, they will use it to begin to generate design ideas. These ideas can then be looked at, improved, discarded, or developed into a final idea or solution to the problem they are solving. From this process comes the final design, which needs to be communicated to the client or used when making the product. There are many different techniques that designers use to develop their ideas and designs and use to communicate these designs. We have identified 6 of the techniques which can be used by the children in primary schools. These are introduced in Key Stage 1 and consolidated and developed as children progress through Key Stage 2. These 6 techniques are using design briefs and design specifications when designing a product, drawing to communicate design ideas, using mood boards to develop ideas and designs for a product, making models, mock-ups and prototypes as part of the design process, using computer software when designing, and brainstorming as a technique to develop and share ideas when designing. When designing products, children do so from a position of knowledge to help them develop their ideas and their designs. And this knowledge can come from a variety of sources and includes investigating existing products. This is about children handling, exploring and playing with existing products, finding out what they do, how they are made, what materials were used to make them and how they work. Children can also undertake market research and desktop research to find out about products. This can be as simple as discussing a product with their friends, reading books about a product, to online research finding out about existing products. Visits allow children to gain more knowledge about a product, how it is used in the real world, who uses the product, and knowledge about how they use this product. Sometimes there can be explicit teaching about products, providing knowledge about what they are, how they work and how they are made. When working with food, it is all about creating a food product that tastes nice and that people want to eat. So an important part of cooking and nutrition is to provide children with opportunities to taste test food and to develop a taste vocabulary to describe the taste, texture and appearance of food. Many of these types of activities are usually carried out towards the beginning of a project and are an opportunity to introduce the project, find out what children already know about a product that they may be designing, how much knowledge they are able to recall from previous units of work and learning, and are also an opportunity to add to children's subject knowledge. Here are some examples from Key Stage 2 projects of how children can be provided with knowledge about products that is then used to inform and develop their own design ideas. In lower Key Stage 2, before designing their own headlamp torch, children investigate torches, focusing on the shape, size, design and materials that they are made from. Further investigations look at the different types of switches that might be used and challenge the children to think about who might use the different torches and for what purpose. When designing and making a healthy lunchtime wrap, children are first given the opportunity to taste and investigate some existing lunchtime wraps that can be bought at the local supermarket. This activity provides knowledge to the children about what a lunchtime wrap is and the types of ingredients that can be used in a wrap, as well as developing their taste vocabulary. This activity builds upon children's learning from Key Stage 1 about taste testing food. Children can also investigate the packaging for each wrap and the information contained on the packaging and labelling. Later, having designed and made their own lunchtime wrap, they will apply this learnt knowledge to design and make its packaging and labelling. In the top activity, children are guided through an activity to create a simple model of a pulley system. This allows them to investigate and acquire knowledge about how a pulley system works, which they then apply when designing a fairground ride that uses a pulley system driven by a motor to rotate the ride. As an introduction to a project about street food, children carry out market research to discover which is the class's favourite types of takeaway food and also where takeaway food can be bought locally. Once children have knowledge of the product, they can begin the process of design using a range of design skills and techniques. The first one we are going to look at is using the design brief and design specifications for the product. Each project that the children undertake should include a design brief that tells them about the product they are going to create or the problem that they are going to solve. Linked to this design brief are a list of design specifications that can include what should be in the product, how it should be made, or how it should work. For the project on screen, children are being challenged to design and make a tote bag. The design brief can be used as a guide for some of the knowledge that the children will need to successfully complete the project. They will need to know what a tote bag is and also to understand the phrase eco-friendly. The design specifications for the tote bag give the exact measurements for the bag and also what should be printed onto the bag in terms of an image consisting of a logo and a slogan. Once children have this knowledge from the design brief and specifications, they can apply this knowledge to design and make their eco tote bag. Drawing is an essential tool of the designer. As children progress through the curriculum, they should learn about different types of drawing and how they are used in the design process. In Key Stage 1, children will learn about how designers use sketching to quickly get down their ideas and how sketching is used to develop and refine these ideas. They also learn how designers use drawings to finalise and communicate their designs and how labels and annotations are used to add more information and help to explain their design ideas. In Key Stage 2, these drawings become more complex and sophisticated, and different types of drawing techniques are introduced. Labels and annotations will be more detailed and help to explain the product's features and how it will be made. In the example on the screen, children use annotated drawings to explain the features of their fashion waistcoat and how it was made. Building on their simple sketches and drawings from Key Stage 1, in Key Stage 2, children can be challenged to realise their designs in 3 dimensions, or to develop their designs by showing the insides of their product by drawing a cross-section design. In the examples on the screen, children use isometric paper to help them draw designs for a wooden base for their table lamp, and cross-section drawings are used to explain how a pneumatic system involving syringes can be used to create movement in a rainforest monster toy. Here are 2 other drawing techniques that can be developed in Key Stage 2. Cutaway drawings are used to show the inside of a product and are often used to explain how the product works and the components which make up the product. Unlike cross-sectional drawings, cutaway drawings are more lifelike and are drawn using 3-dimensional drawing techniques. In the example shown on the screen, cutaway drawings are used to explain how the different components of an electric vehicle are combined to make the vehicle work, and helps when children are designing their own controllable buggy for the Robo-Wars project. Exploded diagrams are another technique for showing how component parts of a product fit together and explain how the product functions. Children can use exploded diagrams to explain how the different parts of a shadow puppet theatre are layered together to make the shadows that tell the story. The key to successful application of each of the drawing techniques is choosing projects and products that are best suited to each of the techniques. Computer-aided design is the use of computer software to create product designs. It is really just another drawing technique that is used extensively by designers in the 21st century. Therefore, using computer-aided design in lessons provides an opportunity to make the subject real-life and relevant. The important knowledge is that children develop an understanding of how computer-aided design allows the designer to change and modify design without completely having to redraw the design. Also, they need to know that computer-aided design allows a designer to easily share their design ideas. For example, electronically via email, social media, or by projection onto a large screen. In Key Stage 1, children may have used computer software to create and modify their design ideas. Children can also be introduced to using 3D drawing software such as Tinkercad or SketchUp. Both programs require the children to create and manipulate 3D shapes to create their designs. In order to be successful in using this software, children should have knowledge of 3D drawing techniques. In the example on the screen, children use Tinkercad to manipulate and combine a range of 3D shapes to create a design for an animal shelter. Having completed the design, they use it when making a prototype of their animal shelter. Sticking with the animal shelter project, creating and using models, mock-ups and prototypes is an important part of the creative process of designing a product. Creating a model, mock-up or prototype allows children to work with materials that are readily accessible and easy to use, such as paper, card and cardboard, as opposed to trying to create an animal shelter out of wood. In Key Stage 2, building upon their experiences of making models in Key Stage 1, children use models to help them to understand how products work, how they are made, and also how models can be used to communicate their design ideas. In this project, children make a model of a shadow puppet theatre using a card template, tissue paper, and a simple electrical circuit to produce light. This teacher-directed activity allows the children to understand how a shadow puppet theatre functions, whilst also consolidating children's knowledge from science lessons on simple circuits. Later in the project, they apply their knowledge and understanding from making this model when designing and making a larger version of a shadow theatre, complete with scenery and movable characters. A mood board is a technique used by designers and is a visual way of developing, sharing and presenting their ideas. A mood board is a physical collection of ideas that are used by designers to bring together their thoughts, ideas, initial drawings and designs into one place. Mood boards can be particularly useful if children are working in a group, as a stimulus for group discussion about their ideas or as a way of recording their ideas following discussion. Mood boards are introduced in Key Stage 1 by creating a whole class mood board display of the children's ideas and designs for a particular product they are designing. As they progress into Key Stage 2, children will be responsible for developing their own mood boards for the product that they are designing, and they should learn more about how designers use mood boards and get better at using mood boards as the part of the creative process of designing. In Key Stage 2, children could be presented with a ready-made mood board which they use to help develop their own design ideas. For example, they could be provided with a mood board about Italian food to help them to develop a menu for an Italian restaurant, or for a poster about an Italian meal they have designed and made. In Key Stage 2, children can be guided to create their own mood boards about a particular product or theme. Developing mood boards can also be linked with other design activities such as group discussions or brainstorming activities, where the outcome of the activity is to develop a mood board of ideas and images. Mood boards are often associated with the fashion industry and fashion designers. In this project, children are challenged to design and make a decorated waistcoat as part of a carnival costume. They are presented with a ready-made mood board containing images of peacocks and fashion waistcoats. They use this mood board to design a peacock-inspired waistcoat as a guided focus task. Later, as part of the design and make activity, they use this experience of using a mood board to create their own mood board on a specific theme for the carnival costume, and then apply their knowledge of using mood boards to create a design for their carnival costume. Brainstorming is a technique that can be used in Key Stage 2 to help children to discuss and develop their design ideas. Like all other design techniques, brainstorming needs to be explicitly taught to the children. Brainstorming is an activity used by designers to generate ideas, solve a problem, or to answer a question. Brainstorming is often done in groups to generate many ideas, where the children are encouraged to go for quantity of ideas and not quality of ideas. But as the brainstorming session progresses and as part of the creative process, these ideas are then refined and whittled down to one final design idea. Capturing children's thoughts and ideas and building on other children's suggestions sparks creativity and innovation in the design process. Children need to understand and apply some simple rules for brainstorming, which are: everyone contributes and all ideas are allowed. Wild ideas are encouraged, with the children creating as many ideas as possible and building on the ideas of other children. Judgment on ideas are postponed and the ideas are owned by everyone. And encouraging the children to remain focused on the brainstorming topic, with children taking turns to speak. Towards the end of the brainstorming session, children can be guided to refine their ideas and to make design decisions about the product they are going to make or the problem they are going to solve. Having an endpoint activity such as drawing their final design, writing a paragraph about their ideas, or answering some simple questions will help to keep the children focused on the brainstorming activity and will help to realise an effective design for their product. Brainstorming is a particularly useful technique if children are working in groups to design and make a product. It helps them to share ideas, consider other children's viewpoints before deciding on a final design, which is then used to make a product. In the examples on the screen, children brainstorm ideas for the ingredients that should be used to make a healthy cereal bar. Using the design specifications and a set of questions to guide them, children brainstorm their ideas for a hands-free torch for a dog walker to use late at night. Children brainstorm their ideas for a fairground ride model, and children share and develop ideas for an airline meal for an eco-friendly airline before writing the menu and the recipes for making the meal. The second phase of the creative process is when children realise their design ideas by making their product by applying their practical knowledge. As well as actually making a finished product as the end point to the project, children could make a model or a mock-up or a prototype of their design as the end point. Like the process of designing, we can break down the making process into 6 different areas: learning a range of practical skills and techniques, knowing and using a range of tools and equipment, applying technical knowledge when making the product, working safely, keeping healthy and working within agreed guidelines, getting organised and getting ready to make the product, and creating a product with a quality finish. Just like for the skills and techniques of designing, learning the practical knowledge of making things that was begun in Key Stage 1 is built upon and developed in Key Stage 2. When making their product, children are taught and practice skills and techniques that allow them to make the product that they have designed. Some of these skills and techniques will be specific to a strand of learning, and some skills and techniques will cross over a number of learning strands and include skills such as cutting paper and cards using scissors. As an example of this, when working with textiles, basic skills such as using the running stitch to join pieces of fabric together will have been taught in Key Stage 1. This skill is revisited in Key Stage 2 to allow the children to practice and consolidate this skill. Also, having learnt this basic stitch, This can be further developed in Key Stage 2 by teaching children the techniques of backstitch and the overstitch when working with textiles. As children develop a range of skills and techniques, they should begin to choose which skills and techniques they will use to make their product. As children progress through the curriculum, they should get better at the skills and techniques that they have been taught. And getting better at skills and techniques means being able to apply the skills more accurately to produce better outcomes, doing the skill quicker while still keeping themselves safe and maintaining accuracy, applying the skill with less adult help and guidance, and choosing which skills to use and selecting the correct tools and techniques. As children progress through the curriculum, they should experience knowing about and using a wider range of tools across each of the strands of learning in design technology. In Key Stage 1, children will have been introduced to some of the basic tools used in cooking, working with different materials and textiles, making structures and creating mechanical systems that make a product work. They should know the names of these tools, what they are used for, and have experience of using them. The range of tools and equipment used by the children is then extended in Key Stage 2. For example, in cooking, children are introduced to cooking with heat and will use a wider range of cooking equipment and utensils as the food products they are creating become more complex. For example, children might use a thermos flask when making yogurt for their layered breakfast product. As children are introduced to making products involving electrical and computer program systems, they will need to be taught how to use a range of new tools and equipment to create the electrical circuits and join the components needed to make their products work. When teaching how to use a range of tools and equipment, it is important that teachers model the techniques correctly and that this is consistent across the whole school. In Key Stage 2, children should develop an understanding of selecting the right tool for the task and being able to use that tool with less guidance and more independence. Technical knowledge is the knowledge of how something is made, how it works, and how it functions as it should. Children should be taught the specific technical knowledge related to the project that they are undertaking and the product they are designing and making. Once they understand this technical knowledge, they then apply it when designing and making their product. In Key Stage 1, the technical knowledge covers the basics of cooking and nutrition and healthy eating, how to make structures that are strong, stiff and stable, and using mechanical systems such as levers, sliders, wheels and axles. The technical knowledge from the national curriculum at Key Stage 2 is as follows. Cooking and nutrition. Children should be taught to understand and apply the principles of a healthy and varied diet, to prepare and cook a variety of predominantly savoury dishes using a range of cooking techniques, and to understand seasonality and know where and how a variety of ingredients are grown, reared, caught and processed. In learning about structures, children should be taught to apply their understanding of how to strengthen, stiffen and reinforce more complex structures. In learning about mechanical systems, children should be taught to understand and use mechanical systems in their products. And examples are given such as gears, pulleys, cams, levers and linkages. When learning about electrical and program systems, children should be taught to understand and use electrical systems in their products, and examples are given for series circuits that incorporate switches, bulbs, buzzers and motors. And they also should be taught to apply their understanding of computing to program, monitor and control their products. This builds and extends upon children's knowledge from Key Stage 1. The additional technical knowledge is introduced that covers electrical and program systems. These are just a broad outline of the technical knowledge from the national curriculum at Key Stages 1 and 2, and teachers need to identify the key knowledge and skills and techniques that will be needed to allow the children to apply this technical knowledge when designing and making their product. In order to keep themselves safe when working across a range of making activities, children should be taught the specific skills and techniques when working with a range of different materials. They should learn to use the correct tools in an appropriate and safe way when applying a range of skills and techniques, such as holding a hacksaw correctly when using it to cut strips of wood, or how a thimble can protect their fingers when sewing. Children should know the specific rules and routines, such as working in a hygienic way when cooking. Schools can support this through having a set of risk assessments that are known and practiced by all relevant members of staff and are regularly reviewed in order to keep the children safe by minimising the risk of harm. Having a consistent approach across the school to teaching the correct skills and techniques to keep the children safe when undertaking practical work in design technology. Having standard sets of equipment that are used correctly and consistently across the school, with all relevant staff members knowing how to use them correctly and being able to demonstrate the correct techniques to the children. Ensuring that the curriculum ensures that children get better at the skills and techniques as they progress through the school. Teachers can support this by knowing the relevant risk assessments of the activity being undertaken and adapting them and applying them to the group of children about to undertake the activity. Knowing the correct skills and techniques when working with a range of materials and being able to model and clearly demonstrate these techniques to the children. Ensuring that children have access to the correct equipment for the making task and know how to use them. And reminding the children of the rules and routines that will keep them safe during making activities. Getting organised is an important part of the creative process of making a product and is also an invaluable life skill. Planning to make is about getting organised and being prepared for the session where they create the product they have designed. This can mean gathering together all the materials or ingredients that they are going to need to make the product, knowing which tools, equipment they will need and the techniques that they will use, and having their designs and drawings that will guide them during the making session. In planning to make, children should have a clear idea of the steps that they are going to undertake in order to make their product. In Key Stage 1, this might be quite teacher-led. But as children progress through Key Stage 2, they need to become more independent in organising themselves and planning out what they need to do to create their product. This is particularly important when children are working in a group to make a product. As well as working collaboratively, children can learn how to assign different tasks or jobs to different group members as part of the design and make process. Some of our projects from the scheme of work introduce children to Scrum boards and Kanban boards that are organisational devices used to assign different tasks within a group. It is advised that when planning out the sequence of learning for a unit of work, for the main making session when the children will create their product, teachers should allocate a specific time for this activity and stick to it. There is no finishing off time. If the product is not completed, then children can reflect on why they did not finish their product as part of the evaluation process. When making their product, children should be encouraged to make it the best that they can. This helps to reinforce the iterative nature of continuous improvement in design technology. Towards the end of the project, as the product nears completion, it provides an opportunity for children to learn a range of different techniques that can be applied to make a quality finished product. Initially taught as a focused task or guided activity, these techniques are then applied by the children to their own product that they are creating. It can be as simple as deciding on a base colour for the product, painting it, leaving it to dry before adding the final details, or it can be teaching a specific decoration technique, such as adding glitter to a product. Section 4 and 5 of the audit covers the disciplinary knowledge of designing and making. Evaluation is the third and final part of the disciplinary nature of the subject. Since they were very young, children have been making choices about what food they eat and they like and what kinds of toys they engage with. As children start school, these choices are further developed and children are provided with the knowledge to make informed choices about different products and are given the skills to articulate their reasons for these choices that they make. This is essentially evaluation. This is made more formal as part of the creative process of design technology. In Key Stage 1, children are introduced to simple evaluation activities that get more complex and sophisticated as they progress through the curriculum. Children are given the opportunity to evaluate the products they have created themselves and also products designed and made by others, including their classmates. They begin by answering simple questions about what they like about the product that they have made and to identify ways in which they might improve the product. Like in other areas of the subject, evaluation skills and techniques need to be explicitly taught. Taste testing is the way in which children can evaluate food. Each unit of work involving food should include taste testing activities. Often, a unit of work will have a taste test towards the beginning of the sequence of learning to teach and consolidate children's understanding of taste tests. Then, after the children have designed and made their food product, they will then conduct a similar taste test to evaluate the food product that they have made. Children will use their senses of sight, smell, taste and touch to evaluate food and use their developing taste vocabulary to describe what their senses tell them about the food. As children progress through the curriculum, they will be extending and developing their taste vocabulary. In carrying out taste tests, there should be a consistent approach to how they are taught and the methods used across the school. Children should know about the health and hygiene considerations when taking part in a taste test, and the complexity and challenge of taste testing increases as children progress through the curriculum. In Key Stage 2, children use a wider range of evaluation activities which are more complex and sophisticated than those carried out in Key Stage 1. On the following 3 slides, there is a brief overview of some evaluation activities that are included in different units of our scheme of work that provide some ideas for evaluation and some ways in which a product that the children can be evaluated. Sometimes more than one of these activities are used as part of the evaluation process. The first way that a product can be evaluated is for children to consider whether they have designed and made a product that fulfills the function that it was designed for. Linked to this activity can be to evaluate the product against the design brief. Have the children designed and made the product that they were meant to do? Have they fulfilled the design brief? They can also use the design specifications to help them when evaluating. The design specifications are a list of things that the product must do to be successful. Have they made and designed a product that meets these design specifications? Children can also use their own personal opinions of their product when evaluating by asking themselves a series of questions about their product, what they liked about the product and the ways that they could improve their product. These same questions can be used when they are asked to evaluate a product that they have not created themselves. In these examples, children carry out their evaluation through a project at the end of the unit of work. They could take part in a show and tell activity where they talk about their product, explain how it was made and what it does, and are prepared to take questions at the end of their presentation. Children could be tasked with making a small documentary film about their product that includes film clips or photographs that show the stages of the creative process of designing and making their product and also shows how the product functions. As an alternative, children create an exhibition stand about their product, again which explains the creative process of designing and making it, and it can include designs, photographs, pictures and explanations about how the product was created. In the final evaluation activity, children are tasked with making a small magazine known as a zine all about their product. In all the activities, children need to know about the evaluation activity early on in the project so that they can keep all their designs and pictures, take photographs and video clips, and gather the resources that they will need in order to complete the evaluation project. Another evaluation activity is for the children to complete a mock-up of an online selling page for their product. This activity challenges them to think about their product and its functions, who they have designed their product for, and the materials that were used to make the product. Having successfully evaluated their product and identified ways in which it might be improved, children could undertake an evaluation activity where they design the Mark II version of their product. This could be achieved through labelling and annotating an existing image of their product, explaining how it could be improved, or this could be done by asking the children to redesign their product to include all the new improvements that they have designed. Children can also be asked to evaluate the process of creating the product by asking them to think about what they enjoyed most about making the product, the skills and techniques that they used, and aspects of the creative process that they found most challenging. As children progress through the curriculum, taking part in evaluation activities, they should be reminded of the iterative process of ongoing evaluation when designing and making. What we are looking for is to instill the mindset of how can I make this better as the children are actually working. As part of the disciplinary process of design technology, children need to develop a technical vocabulary that allows them to access and fully understand the lesson content, communicate, articulate and discuss their learning, and allows them to understand more about the subject and conduct their own independent research. Many of the technical words in design technology are words that do not appear in any other curriculum area, and therefore they need to be taught and their meanings and application in the subject needs to be understood. This Tier 3 technical vocabulary may include words specifically linked to technical knowledge and the skills and techniques that children will learn as they progress through the curriculum. They may be words that are linked to the disciplinary nature of designing, making and evaluating. As with many aspects of design technology, teacher subject knowledge may hinder effective teaching of vocabulary in the subject. It is recommended that schools develop a vocabulary of words and their meanings that are used consistently across the key stages in design technology. Once this has been established, then planning documents for a unit of work can include the vocabulary that will be used and taught within the units of work. Many schools, as part of their progression document, have gone further by highlighting when new words from the vocabulary list will be first introduced to the children. This is good practice as it will inform the pedagogy of teaching this vocabulary. If the word is new, then the teacher should spell the word, explain its meaning and then model using the word in a sentence and highlight its use throughout the unit of work. If it is a word that the children should know already, then they should be given the opportunity to explain its meaning and then use the word correctly within a sentence to illustrate their understanding of the word and its meaning in context. A vocabulary list can be downloaded from the Primary DT website as the basis for schools developing their own technical vocabulary list. Every lesson from each unit of work in the Primary DT scheme of work begins with vocabulary development, focusing on 3 words from the vocabulary list that are related to the learning content for the lesson. Section 6 of the Audit of Provision focuses on the disciplinary knowledge of evaluation and the range of different activities in the curriculum to develop children's skills in evaluating products and also develops their understanding of evaluation as part of the iterative nature of the subject. Section 8 specifically focuses on how vocabulary is developed as children progress through the curriculum, through planning for opportunities to teach the technical words of design technology. The Design Technology National Curriculum at Key Stage 2 states that when designing and making, pupils should be taught to understand how key events and individuals in design and technology have helped shape the world. In 2019, Ofsted added the term cultural capital to its school inspection handbook, which is described as the essential knowledge that pupils need to be educated citizens, introducing them to the best that has been thought and said, and helping them to engender an appreciation of human creativity and achievement. Learning about iconic designs and designers fulfills these requirements and also helps children to understand and put the discipline of design and technology into the context of the real world by allowing children to understand what designers do and how they work. In primary school design technology, most of the focus, quite rightly, is children designing and making a product. But design is much more than this. Learning about designers and their designs helps children to understand that designing is also about being creative to solve a problem or find a solution to a problem. Learning about designers and their designs allows children to study people who are good at the subject and helps them to understand what designers do, puts the subject into context by providing examples of design technology that is real life and relevant, and allows children to reflect on how the subject affects the lives we live today. Learning about designs and designers consolidates children's understanding of the relationship between the designer, the product, and the client. A designer is someone who has ideas and creates plans for making products. A product is something that is made to do a job or fulfill a need, and a client is someone who needs, wants, or buys a product. This relationship and understanding that a successful designer designs a product that the client will use or buy is essential knowledge that children should apply in every project that they undertake in design technology, where they are tasked with designing and making a product for an intended user. Learning about designs and designers is a very small part of the overall DT curriculum, and so not every unit of work needs to include some elements of studying designs and designers. Some units of work are better suited than others. Over the course of a scheme of work, children should have the opportunity to learn about a range of different designs and designers, including inventors, inventions and innovators, fashion designers, and chefs and cooks. Here are some ideas taken from our scheme of work. As part of their challenge to design and make a waistcoat for the class fashion show, children research and learn about the life and work of the iconic British fashion designer Dame Vivienne Westwood and present their findings as a PowerPoint or a poster or a mood board, or as a written piece of work such as a biography. As an alternative, they could research the life and work of a different fashion designer such as Oswald Boateng, Stella McCartney or Bianca Saunders. When developing ideas around food entrepreneurship in cooking and nutrition, children learn about the achievements of the young British food entrepreneur Amari McQueen. In addition to his social media output, he became the world's youngest restaurateur when he set up his own pop-up vegan restaurant. Also, when studying cooking and nutrition, children can learn about the chef Jamie Oliver, and in particular his campaign to improve the quality of school lunches that began in 2004. Learning about designs and designers also provides an opportunity to address how designers are often used to solve a problem or find a solution to a problem. So, for example, when learning how to design and make pizza, children can also be taught about the designer Ingrid Kosa, who solved the problem of pizza deliveries in the 1970s that were arriving cold and soggy. She invented a delivery bag made from Thinsulate, which was a fabric used to make downhill ski racing suits. This created a bag which could breathe but also kept its contents hot. When designing and making a robo-war vehicle, children could learn about the achievements of Elon Musk in developing the Tesla electric car, Starlink satellite Wi-Fi system, and the SpaceX rocket program, and how these might impact on daily life. As part of evaluating products, children can reflect on the knowledge and skills that they themselves have learned when creating the product, and how these might be used in later life and in the world of work. Section 7 of the Order of Provision allows you to identify opportunities for children to learn about designs and designers that have shaped the world. In this section of the presentation, we are going to look at the technical knowledge and the associated practical knowledge and skills for each strand of learning in Key Stage 2. The technical knowledge in Key Stage 2 builds upon children's knowledge and experiences in Key Stage 1 in the areas of cooking and nutrition, using the basic principles of a healthy and varied diet to prepare dishes and understand where food comes from, creating products from sheet materials and textiles, building structures and exploring how they can be made stronger, stiffer and more stable, and exploring and using mechanisms in their products. Key Stage 2 also introduces new technical knowledge around 2 additional strands of learning: electrical systems and programmed systems. We will begin by looking at cooking and nutrition, which is a key component of the design technology curriculum. Many schools in England devote a third of curriculum time to this strand of learning. This equates to 1 unit of study per year group. Teaching cooking and nutrition each year means that it is the easiest strand of learning to demonstrate progression, but conversely also highlights lack of progression. It is therefore important to carefully sequence learning so that children are building their knowledge in each lesson and each unit of work. Such is the importance of this strand of learning in the DT National Curriculum that it devotes a separate section to cooking and nutrition, which is displayed on the screen now. The key areas to focus on in primary schools are teaching children how to cook using a range of techniques, the principles of healthy eating, to know how to prepare and cook a range of mainly savoury dishes, to know and understand where food comes from, and to understand seasonality and how this affects food production. We can break down the national curriculum for cooking and nutrition into 5 main areas. This is what we might call the core knowledge, and that is healthy eating, keeping safe and healthy when working with food, knowing and applying a range of cooking skills, knowing how to follow and write simple recipes, and food origins, knowing where food comes from. These will have been introduced in Key Stage 1, and learning in Key Stage 2 extends, consolidates and deepens children's knowledge and understanding in these 5 areas. Healthy eating is at the heart of the cooking and nutrition curriculum. In Key Stage 1, children were taught to use the basic principles of a healthy and varied diet to prepare dishes. In our scheme of work, this centres around the key messages of eating at least 5 portions of fruit and vegetables a day, cutting down on sugar and salt, drinking 8 cups of water a day, and making the right choices to have a healthy and balanced diet. In Key Stage 2, children's knowledge and understanding of healthy eating is deepened by introducing the Eat Well Guide for Healthy Eating, which should act as a guide for them when designing food and meals that are healthy. Schools should have a clear message about healthy eating that informs both the curriculum and all other aspects to do with food in the school, such as school dinners, packed lunches, playtime snacks and treats for birthdays. This healthy eating message should be adhered to and modelled by all members of the school community. The Eat Well Guide is based on the government's 8 tips for healthy eating, which are: base your meals on starchy foods, eat lots of fruit and vegetables, eat more fish, including a portion of oily fish each week, cut down on saturated fats and sugars, try to eat less salt, get active and be a healthy weight, don't get thirsty, and don't skip breakfast. A separate presentation can be downloaded from the Primary DT website covering healthy eating at Key Stage 2. The knowledge contained in this presentation should form the basis of teaching and learning in Key Stage 2 and underpin all learning activities in cooking and nutrition. In Key Stage 1, children are introduced to the routines and practices that will keep them safe and healthy when working with food. As they progress through Key Stage 2, they should consolidate this understanding and become more skilled and independent in carrying out these routines and practices. In addition to maintaining good personal hygiene when cooking, children should be wearing appropriate clothing, including an apron. Children should be clear about the routines to be followed when testing and tasting food. Schools should adopt a clear and consistent message for children to keep safe and healthy when working with food. These are routines and practices introduced in Key Stage 1 and built upon and consolidated throughout the primary years. The cooking and nutrition curriculum in Key Stage 2 provides an opportunity for children to learn about food labelling and the information contained on food packaging that can help them to keep safe and healthy. Children can learn about the reasons why food products are packaged and the type of information found on food packaging and labels. They can be introduced to the traffic light system and link this to their learning about healthy eating. They should know the importance of storing food in the correct way and why certain foods are kept refrigerated. This can also be an opportunity to teach children about allergies and food intolerances, and children can be made aware of any children in the class who have these allergies or food intolerances, and told not to share ingredients or equipment that has come into contact with ingredients that could cause harm to other children. As well as understanding the importance of good food safety and hygiene and getting ready and prepared when working with food, children should be taught a range of cooking skills as they progress through the curriculum. The skills and techniques may depend on the curriculum content. In Key Stage 1, they are cutting and holding food using the bridge hold, cutting and holding food using the claw grip, weighing and measuring food, grating and juicing. Other skills might include crushing using a mortar and pestle or garlic crusher, peeling, spreading, rolling, mixing and sifting. These cooking skills are revisited and practiced throughout Key Stage 2. Also, as part of their learning in Key Stage 2, children are introduced to skills of cooking with food with heat using techniques such as baking, frying and grilling. As children progress through the curriculum, they are getting better at these skills and techniques by choosing the appropriate skills and techniques to use, choosing the appropriate tools and utensils to carry out these skills, and applying the skills and techniques more independently, more accurately, quicker and safer. It is important that these skills and techniques are taught consistently across the school, using standard sets of equipment and utensils. This will reduce the risk of children harming themselves. An example of a cooking skills progression chart can be downloaded from the resources section of the Primary DT website. This can be edited to show at which stage of the learning journey children are introduced to each cooking skill and technique. Being able to follow a recipe to create a food product is an important element in cooking and nutrition. A recipe is a set of instructions that provide step-by-step guidance to create a food product. A recipe is also a way of communicating the end point of activities where children are designing food. In Key Stage 1, children will have learnt how to follow a recipe to make a food product. They may know some basic recipes and will have begun to understand how to write a recipe. Key Stage 2 builds on this learning by challenging children to design their own food products and dishes. They do this by adapting an existing recipe. They may adapt the recipe to meet the requirements of the design brief and the design specifications, or they may adapt the recipe to suit a particular user. So for example, they may design a pizza suitable for a vegetarian or a vegan. As children progress towards the end of Key Stage 2, they should be expected to design food products and meals based on the principles of healthy eating and write the recipes for these products and meals. Food origins is about children understanding where the food they eat comes from. In Key Stage 1, children will have learnt that the food comes from plants and animals, much of which is produced on a farm. They will know the names of some common food commodities and how and where they are produced. They will also know that different foods come from all over the world. In Key Stage 2, this is further developed by children knowing which foods are grown, reared and caught, and that foods may be processed before we eat them. They can learn about some common processed foods such as bread or yogurt and understand how they are processed and their journey from farm to fork. Cooking and nutrition units of work are also opportunities for further learning about food production in terms of the different staple foods that are eaten around the world, sustainable and eco-friendly food production, fair trade food, sourcing food locally, and understanding the role of different food groups, nutrients, minerals and vitamins in keeping our bodies healthy and fit. The other aspect of food origins that children need to know in Key Stage 2 is the seasonality in food production. When learning about seasonality, children should know and understand that plants need certain conditions to grow well, and these conditions are affected by weather and climate. In the UK, different fruits and vegetables finish growing and ripen at different times of the year, and therefore fresh foods are only ready to eat during certain periods of the year. Other areas of the world have different climates and seasons, and therefore food can be imported from these countries and be available in the UK to buy all year round. Children can be taught about the advantages of eating seasonal foods and be encouraged to use seasonal and local grown food in their classroom cooking activities. Children could also be taught how greenhouses in the UK can produce fruit and vegetables all year round, but use up lots of energy for heating them up, refrigeration, storage of the produce and energy for transporting the goods. As well as the core knowledge that must be covered to meet the requirements of the national curriculum, learning in cooking and nutrition provides opportunities for additional knowledge and learning that can be linked to other curriculum subject areas. In our scheme of work, we have included opportunities for further learning about different diets, allergies and intolerances, studying people who do it well, and food entrepreneurship. As part of the additional content in cooking and nutrition, children could learn about different diets and the choices that people make about the food that they eat and the reasons for these choices. Children could learn that a diet is food that a person eats regularly, and people have different diets for different reasons. People's diet is often influenced by what types of food they like, but there are also a range of reasons and influences on an individual person's diet. Their diet can be influenced by where they live and the food that is grown and available to eat. Dietary choices are often linked to different cultures and traditions. In a multicultural society such as the UK, this is an opportunity to learn about and celebrate these different cultures. Many religions have traditions and rules associated with the food that the followers eat. Often certain foods are associated with different religious festivals and celebrations. Again, this presents an opportunity to include these within the cooking curriculum as an opportunity to celebrate and appreciate the diverse communities in which we live. Some people's diets are limited because of food allergies and intolerances, and they do not have a choice about some food substances they cannot eat. The incidences of children with allergies and intolerances is increasing in schools, and therefore it might be worthwhile to include some learning about this part of the cooking and nutrition curriculum. Children should know and understand the difference between an allergy and an intolerance. This can be linked to children learning the importance of knowing the ingredients contained in different foods and how food labelling is used to provide this information. Some people choose not to eat meat or food from animal products. More children are making the choices earlier to become either vegans or vegetarians, and schools may decide to include elements of understanding why people make these choices. In terms of design technology, learning about different diets presents the opportunities for children to design and make food for special occasions, religious celebrations, or to design food specifically for people based on their diet choices, such as vegans or vegetarians. Part of the disciplinary knowledge of understanding how the subject works is to learn about people who do the subject well. Cooking projects provide opportunities to study people who make their living from food or who have made a difference in the world of cooking and nutrition. In our scheme of work, we focus on people who have made this difference. Children learn about the TV chef Jamie Oliver. In particular, we focus on his work to improve school dinners and reduce childhood obesity. Amari McQueen is a young food influencer who the children may know from his YouTube channel or see BBC TV programmes. He is an example of a young food entrepreneur who set up his first vegan food business at the age of 11 and has authored several vegan cookbooks. Towards the end of Key Stage 2, children can learn about food entrepreneurship linked to the food product that they are creating. Children learn that an entrepreneur is someone who starts a business that either has a product to sell or offers a service that people will pay to use. Children learn about some of the basics of running a business, such as branding, marketing and budgeting. Children have the opportunity to apply their knowledge of cooking and nutrition to create a food product that people will buy. Children have the opportunity to apply their knowledge of packaging and labelling to create a packaged food product. And through these activities, children will develop some of the skills of entrepreneurship, such as setting and achieving goals, writing an action plan, creating a product that people will want, working as a team and leading a team, practicing skills to improve them, and appreciating the value of sharing their knowledge and learning from others. So here is an example of a unit of work from Upper Key Stage 2 called the Eat Well Pizza. For this project, children design and make a pizza, applying their knowledge about and guidance from the Eat Well Guide for Healthy Eating. The project begins with children discussing and investigating takeaway food found in the local area, and this could lead to a discussion about how healthy is takeaway food. They undertake market research about their favourite pizzas and why they each prefer different pizzas. They have the opportunity to taste test pizzas, extending their taste vocabulary and consolidating their understanding of taste tests. As part of a focused task, they all make a simple margherita pizza. This provides opportunities to practice key cooking skills and ensures that the children understand the recipes and processes for making a pizza. The design brief and specifications ensure that they apply their knowledge and understanding of the Eat Well Guide on healthy eating and the different food groups. Having already followed a recipe to make a pizza, they then adapt this recipe to fulfill the design brief and specifications. They draw their design for their pizza and use labels and annotations to explain how it is a balanced meal. They then follow this by writing the recipe for the pizza. This project is also an opportunity to look at food labelling and food packaging and to explore the nutritional content of food. The project completes with the children setting up a business as a food entrepreneur. In another example, this time from Lower Key Stage 2, children apply their knowledge and understanding of seasonality when designing and making a savoury tart. The project begins with children recalling and extending their knowledge of fruit and vegetables, particularly around knowing which food can be eaten raw and which needs to be cooked, and identifying their tastes as either sweet or savoury. In following a recipe to make jam tarts, children learn how to make short crust pastry, and that a tart is a pastry case with a filling made from fruit and vegetables. Making jam tarts is also an opportunity to learn about the different ways in which foods are preserved, and that jam is a way of preserving fruit. Children will learn that certain fruits and vegetables are only available to eat at certain times of the year, and this is called seasonality. Applying their knowledge and understanding of making jam tarts and seasonal foods, children then design and make a savoury tart using seasonal fruit and vegetables. As well as the resources that can be downloaded from the Primary DT website, the Food A Fact of Life website is your one-stop shop and the main resource for teaching cooking and nutrition in primary schools. Further resources that support teaching and learning in cooking and nutrition can also be found on the BBC Bite-Size Design Technology website. In Key Stage 1, children should have the opportunity to work and make with a range of materials, including food ingredients, textiles and sheet materials such as card, cardboard and paper. They may have used materials such as straws, lollipops and wooden strips to make framework structures. Through working with a range of materials, they will be developing an understanding of their different properties and how these may affect choices made for which materials to use when making products. When working with a range of different materials, children should experience and develop skills and techniques to use these materials when making a product. These include measuring them and marking them out, cutting and shaping them, joining them together both permanently and temporarily, and a range of finishing and decorative techniques. In Key Stage 2, children's experiences will be built upon, and children will gain knowledge about working with a wider range of materials and their properties and the associated tools and techniques in each unit of work that they undertake. In the example on screen, children learn specific cardboard engineering techniques that they apply when making products and structures out of cardboard. Creating products using fabrics and textiles provides an opportunity for children to further their knowledge of working with sheet materials. Although not specifically referenced in the national curriculum, working with fabrics and textiles is an effective way of developing children's knowledge of working with sheet materials, as well as giving them opportunities to make quality products. In Key Stage 1, children learn the skills and techniques of cutting textiles and joining fabric pieces together by sewing, gluing and stapling. They are taught the running stitch to join two pieces of fabric together to create a permanent join. Teaching this technique also provides an opportunity for children to learn how to use a thimble and a needle threader when sewing. Children can practice their sewing techniques by using binker material, which they decorate by creating patterns using a range of embroidery stitches. In Key Stage 2, children create products using textiles as they extend their knowledge of sewing techniques by learning new stitching techniques such as the back stitch and the overstitch. As part of the design process, children in Key Stage 2 create pattern templates that are then used to cut out fabric pieces that are then stitched together to create the product. Children in Key Stage 2 can also be taught about different fastenings that can be used to temporarily join textiles, such as buttons, stud poppers, velcro and zip fasteners. In Key Stage 2, children can also learn new decorative techniques such as applique, tie-dye and embellishment of their textile product. Textile products that children design and make in Key Stage 2 will be more complex and sophisticated than those created in Key Stage 1 and could include cushions, mobile phone covers as shown on the screen now. And here are examples of money containers and purses, soft toys for a fundraising charity, an electronic interactive soft toy, and a waistcoat made from a teddy bear mascot. These are projects that feature in our scheme of work and are textile based. In Key Stage 1, children will have created structures by joining different materials together and exploring how these structures can be made stronger, stiffer and more stable.
The materials used will have included paper, card and cardboard, and they may have made framework structures using wood strips or lollipop sticks. Children will have developed and extended the range of tools and techniques that they use when creating these structures. As they progress into Key Stage 2, children will apply their knowledge of different materials, tools and techniques to design and make more complex structures. Some structures will be the actual product, and some structures will be created as part of an overall product. In Key Stage 2, children's knowledge of structures can be extended to include shell structures. They will learn that a shell structure is a hollow structure made from a thin outer layer, and that shell structures get their strength, stiffness and stability from both their shape and the materials that they are made from. They can apply this knowledge when making papier-mâché shell structures that they then combine together to create a desk tidy. They could also apply their knowledge in making nets of 3D shapes to create packaging for their product. This is another form of shell structure. In Key Stage 2, children can also build on their knowledge and experience of making framework structures. If they have used the Jinx method in Key Stage 1 to create a simple wooden frame, then this can be extended in Key Stage 2 to create a box framework that can be used to create a wooden framework for a mini greenhouse or for an animal home for the school garden. Here are some more examples of framework structures in Key Stage 2 taken from our scheme of work. Children use a simple wooden frame as the main structure when creating a photograph frame. Children make simple wooden frameworks when creating a shadow puppet theatre and scenery. Children apply their knowledge of framework structures and cardboard engineering when they create a mock-up of a marble run toy. Children create a box framework to hold the cam mechanism when creating an automaton toy. When learning about mechanical systems in Key Stage 1, children are introduced to the idea that all systems have an input and an output, and that systems make a product work. This key knowledge is consolidated and built upon as children progress through Key Stage 2, with the opportunity to gain knowledge about more different mechanical systems. In Key Stage 1, children may have learnt about mechanisms such as sliders, levers and wheels and axles, which create movement in their product and make them work. In Key Stage 2, additional mechanisms such as levers and linkages, pneumatics, gears, pulleys and cam mechanisms can be taught to the children. With regards to levers and linkages, in Key Stage 1, children will learn that a lever is a very simple mechanism that has a bar or rod that moves in a rotational direction. The bar rotates around a fixed pivot. In Key Stage 2, children are taught that joining two levers together using a loose pivot creates a linkage mechanism. In the examples on screen, children learn about a range of different linkage mechanisms that produce movement having different inputs and outputs. They then apply this knowledge to create a mechanical book page that has an element of movement created by a linkage system. Pneumatics is not specifically mentioned in the national curriculum, but is an effective way of teaching key knowledge about mechanical systems, which is systems have an input and an output, systems make a product work, and mechanical systems produce movement. A pneumatic system is one that uses the pressure of compressed air to make something move. In primary schools, this compressed air is created by inflating a balloon and using the pressure to cause movement, or by creating a simple system involving syringes connected together using plastic tubing. In the Rainforest Monster project, children create a simple mechanical toy based on a rainforest animal that has a moving mouth, where the movement is caused by a pneumatic system created by joining together two syringes using plastic tubing. Gears are another form of mechanical system used to create movement. Gears are essentially wheels with teeth that transfer movement and can change the speed and direction of movement. Knowledge and understanding of gear mechanisms is used to create a model solar system in the Orrery project. Having created a wooden framework box
a gear mechanism is added that changes the vertical rotational movement when the user turns the handle into the horizontal rotation of the solar system model. Changing the size of the gears in the system will affect the speed of rotation of the model. A pulley system is a mechanical system that transfers movement from one pulley wheel to another pulley wheel. The pulley wheels are connected by a pulley belt. Changing the sizes of the pulley wheels relative to one another will affect the speed of the pulleys. Crossing over the pulley belt results in a change of direction in one of the pulleys. Pulley systems can be used to drive the wheels of a buggy or to create a simple model of a drawbridge or a water well. In the fairground model project, the driver pulley is replaced by a motor which rotates the driven pulley, causing the fairground model ride to rotate. Using computer software and block coding allows the user to control the speed and direction of the motor and of the fairground ride model. Like for the orrery model, the mechanical system is housed within a wooden framework. A cam system is a mechanical system that is used mainly to transform rotational movement into linear movement. The shape of the cam affects the type of linear movement that is produced. Like for the orrery model and the fairground ride model, the mechanical cam system is housed within a wooden framework which provides strength and stability for the model. In the example on screen, children design and make an automaton model which moves when the handle is turned. Children decide the type of linear movement that is needed and create a cam mechanism that produces this movement. The automaton on screen has a Christmas theme but can be easily adapted to suit many different themes. In Key Stage 2, children are introduced to using an electrical system to make their product work. Usually this consists of one unit of work that is delivered in lower Key Stage 2 when children have learnt about simple circuits as part of the science curriculum. The most suitable electrical system to use is a simple circuit involving a battery, light and switch. This involves children knowing and understanding that the switch controls the input, which is electricity, and the output, which can either be light, movement or sound, and knowing how to create the electrical system as a component of the finished product. For the project on screen, children design and make a simple table lamp by combining 3 different component parts. A simple wooden frame that acts as the lamp stand, a light shade made by creating a shell structure from tissue paper and papier-mâché technique, and a simple light circuit with a switch. Other projects that involve electrical systems can include designing and making a torch or a model of an alarm system. Program systems are normally taught towards the end of Key Stage 2 and build upon children's experiences of using electrical systems in their products. With program systems, children need to know and understand that the inputs and outputs are controlled by a microcontroller that is itself programmed using block code. Inputs are more sophisticated than a simple switch, as a programmed system can incorporate sensors that detect changes in the immediate environment such as light, sound and movement. In the examples on screen, children design and make a digital decoration that produces images and sounds when different input buttons are pressed on the microcontroller. The decoration switches itself on automatically when it becomes dark, sensing changes to the light intensity of the environment. This product incorporates a BBC microbit controller. In the second example, children create a RoboWars vehicle using Crumble Kit. They join together motors, lights and switches to create a buggy capable of random movement. Section 9 of the curriculum audit covers the technical knowledge linked to the strands of learning in DT. Some children will demonstrate a high level of understanding and ability in design technology, whilst others may struggle in the subject or aspects of the subject. All should be supported to ensure that they all achieve the designated learning outcomes for each project. In this short section, we provide some generic challenge and support strategies that can be used to support teaching and learning across the design technology curriculum. Also, as part of the planning process,
teachers should consider specific resources and strategies that can challenge and support children specific to the unit of work they are planning to deliver. Challenge strategies are for those children who demonstrate an increased understanding or ability in the subject. These children should be provided with opportunities to deepen their understanding of the curriculum content. Challenge does not mean introducing new curriculum content or knowledge. Challenge strategies can include encouraging children to go deeper into the iterative process, to challenge them through each of the phases of the iterative process to improve on their designs or to add more detail or a higher quality finish to their product. It can also be about higher expectations and detail and sophistication in their designs. Challenge can also be about encouraging these children to show leadership and delegation when working in group-based activities and situations, or to act as a buddy or a mentor to a child who may struggle in the subject. Here are some strategies that can be used to support children to ensure that they can achieve the learning outcomes in design technology. Some children may not have secure knowledge in some key skills and techniques, and so during the investigative and focus sessions, teachers can identify the children who need additional support in the design and make and evaluation activities. To enable children who may struggle to gain the necessary knowledge, skills and techniques, consider one-to-one or small group work with adult support when undertaken focused tasks and practical activities. If learning in the session requires children to retrieve previous learnt knowledge, then check that they have, and if not, pre-teach this knowledge. Ensure that children fully understand any technical vocabulary for the learning session through pre-teaching and prompt cards. To enable children to fully engage in discussion and brainstorming activities, provide them with ready-made questions. Some children may struggle to communicate their ideas when designing a product. Use adult support or another child to act as a scribe to write down or draw their design ideas. Design activities can also be scaffolded to help children to realise their design ideas. This can be achieved by providing children with drawings for them to label and annotate, or providing them with keywords and annotations to add to their drawings. When working in group activities, make informed choices about these groupings or consider buddying up children who may be struggling with a more able pupil. Some children may not be able to accurately carry out necessary skills and/or techniques to enable them to successfully complete the design and make project, but this should not exclude them from making and completing their product. Provide them with the necessary materials, tools and techniques to support them. So for example, if a child struggles with accurately measuring and cutting strips of wood, then provide the children with pre-cut wood for the design and make activity. Or provide children in cooking activities with prepared and measured ingredients to enable them to follow the recipe to create their food product. When evaluating products, children could work as part of a guided group or have guidance to follow or to answer a set of questions to enable them to evaluate effectively. One of the phrases that has been often used in this presentation has been "as children progress through the curriculum," because the essence of learning in a subject is that you get better at the subject the more you study the curriculum, navigating the knowledge to reach the curriculum endpoints. This is progression. In considering progression and assessment in design technology, we need to consider one of the underlying principles of the subject, that children build knowledge. To ensure the curriculum promotes knowledge building, we need to develop a curriculum that sets out explicitly what the children are expected to know and remember at each stage of their learning journey. And this can be done at various stages, at each lesson, in each unit of work, in a year group and over a key stage. And this is the knowledge from the four domains of subject knowledge, disciplinary knowledge, practical knowledge and technical knowledge. We also need to develop a curriculum in which teaching and learning is based on securing this key knowledge and making sure that the children know and remember it. We need to develop a curriculum where knowledge is carefully sequenced with plenty of opportunities throughout the learning journey to revisit and recall this knowledge, linking it together and adding new knowledge to create a better understanding of the subject. Mapping out the knowledge that children are expected to know and remember is the purpose of a progression document. Not only does it sequence children's learning, it can also be used by teachers to identify what the children should know already from previous learning, and also the knowledge that they are expected to teach to the children that will be built upon in later years. An effective progression document maps out the learning journey from early years right through to the end of Key Stage 2. It is a roadmap that details the learning journey and knowledge acquisition that the children need to reach the early learning goals at the end of the foundation stage and at the end of Key Stage 1 and Key Stage 2 expectations. Taking time to develop a detailed progression map which clearly states what the children should know and remember supports effective assessment in design technology. Teachers identify whether the children are on track and are expected to reach the end of key stage expectations. In other words, do they know and can they remember the knowledge that they are supposed to at the end of their learning journey, or are they working towards the expectation and need further support to reach these expectations? In our scheme of work, we include 5 indicators for each unit of work to show that children are keeping up with the curriculum. This can help teachers to make a judgment about whether individual children are where they are expected to be and that the teacher is confident that the child is on track to reach the end of key stage expectations. This screen also shows how in the medium-term planning in the scheme of work, children can be challenged by deeper learning and supported to achieve the learning outcomes. Progression through the curriculum is often demonstrated through a progression document. There are many different formats for progression documents, but all should focus on identifying the key knowledge that children are expected to know at each stage of their learning journey. In our scheme of work, we have divided the knowledge into what children should know and what children should know how to do. These simple statements allow teachers to make a clear judgment. Do they know it, yes or no? And if they don't know it, then reteach this knowledge. In the example on screen taken from our scheme of work, the knowledge that the children should know about the disciplinary process of designing is indicated for Key Stage 1, Lower Key Stage 2 and Upper Key Stage 2. As well as making progress in the disciplinary knowledges of designing, making and evaluating, children also need to make progress in the technical knowledge for each strand of learning in design technology. And again, we use the same format in our progression document. Schools in the Flying High Partnership that are separate infant and junior schools might like to consider collaborating together on their overall DT curriculum or progression document to ensure that children continue to build knowledge and continue to make progress in the subject when they transfer schools from Key Stage 1 into Key Stage 2. Our progression document, called the Curriculum Pathway, can be downloaded from the Resources section on the Primary DT website. Section 10 of the Curriculum Audit focuses on curriculum progression and assessment, and Section 11 of the audit looks at the overall curriculum structure and the rationale for it. Just a reminder that there is a dedicated page on the Primary DT website for schools in the Flying High Partnership. We hope you have found this presentation useful and informative.